Good morning to all of you. Today we are going to study about some example of continuity. Now problem first जो है if f equal to 1 minus cos 4x divided by x square if x less than 0 and equal to a if x greater than 0 and here under root x by under root 16 plus 16 plus under root x minus 4 x greater than 0. Now f is continuous at x equal to a, x equal to a, x is the continuous, this is equal to 0. F is continuous at x equal to a, then find the value of a. We have to calculate the value of a. Now we calculate left hand limit x tends to minus 0 left hand limit. It means that x value of x less than 0, value of x less than 0, so that this function 1 minus cos 4x by x square, and so that 1 minus cos 4x by 4x square, because here is 4x square, so that value of this is equal to half, and arrange this 4 के power 2 here, 4 के power 2, value of this is half and into 16 equal to 8, and right hand limit 0 plus x tends to 0 plus fx बराबर limit x tends to 0 plus fx any greater than 0, we take this under root x divided by root 16 plus under root x minus 4. On rationalizations, here minus, we take the positive and multiply and divide this, This comes here, and a minus b and a plus b, a square minus b square, only 16 plus under root x, and minus 4 4 16. 16 remove, and this also remove, so that only these terms rest here. Under root this, putting x equal to 0, this is 0, under 16 is equal to 4 and 4, 8, so that f0 minus f0 plus, that is equal to 8, value of 8, so that a equal to 8, this is our required answer. Now take next problem. Now second problem, fx equal to e to the power x minus 1 x cube cosec ax divided by ln 1 plus x square if x does not equal to 0 and equal to b if x equal to 0. Find the value of ab if x is continuous at x equal to a. Now fx equal to e to the power x minus 1 to the power 3 bar and cosec ax divided by ln 1 plus x square, and x does not equal to 0, it means that 0 plus and 0 minus, we take the value, and b at x equal to 0, this is continuous at x equal to 0, limit x tends to 0, fx limit x tends to 0. Now e to the power x minus 1 का cube cosec ax divided by here x cube, because e to the power x minus 1 by x, e to the power x minus 1 by x equal to 1, so that we multiply here, and this is here, and this comes here, x square and ax by ax. Now arrange this here, ex minus 1 by x to the power 3, and ax comes here and divided by sine ax, and here ln 1 plus x square divided by x square. This here, this is x square and x cube, and this arrange here x cube cancel, and here this comes here and this 1 by a. Now this is cancelled, so that value of e to the power x minus 1 divided by x, limit x tends to 0 equal to 1, 1 to the power q equal to 1, and ax by sin ax, limit x tends to 0 is also 1, and ln 1 plus x square by x square, that is equal to 1 here, and this cancel 1 by a, so that this is equal to 1 by a, and f 0 equal to 1 by a, so that f 0 equal to f minus 0 equal to 1 by a, because f is continuous and x equal to 0, so that f0 plus f0 minus equal to this, that is equal to also b, so that 1 by a equal to b, therefore ab equal to 1, and find ab if f is continuous at x equal to 0, so that value of ab equal to 1. This is our answer. Now, third problem is f is equal to x plus a root 2 sin x vary from 0 to pi by 4. Fx is equal to 2x cot x plus b, where x vary from pi by 4 less than equal to x less than pi by 2, and fx vary from a cos 2x minus b sin x vary from greater than pi by 2 and less than equal to pi. F is continuous in 0 and pi. This is 0 and pi. Find a and b, value of a and b. Now at the point pi by 4, here, pi by 4 here, this is a pi by 4 here, negative, so that we put here x equal to pi by 4 and a root 2 sin pi by 4 equal to 1 by under root 2 cancel, so that pi by 4 plus a, and plus pi by 4, it means that this in this region 2x plus pi by 4 cot pi by 4 plus b, and this is equal to 1, and pi by 2 plus b. Now at pi by 2, negative sin pi by 2, this negative, this comes here 2x into pi by 2 into cos pi by 2 plus b, and cos, this is cos pi by 2 means cos 90 divided by cos 90 equal to 0, so that these terms will be 0 and only b remain. Now cos f pi by 2 plus in this case to a cos 2 into pi by 2 minus b sin pi by 2, and here this 2 and 2 cancel, cos pi means minus 1, this is equal to minus a, and sin 90 degree equal to 1, so that minus b, and now f of minus pi by 2 equal to, because f is continuous at 0 to pi, so that f minus pi by 2 के power minus and plus both are equal, so that this value is equal to b, equal to this value minus a minus b, so that b comes here 2b equal to minus a, so that b equal to a minus a by 2, and now minus pi by 4 and plus pi by both are equal, so that this pi by 4 plus a equal to pi by 2 plus b. Now pi by 2 plus b, value of b equal to minus a by 2, so that putting the value of b minus a by 2, this a and negative comes here plus a by 2, and pi by 2, this comes here minus pi by 4. After subtracting, this is equal to pi by 4, and 202 on 3 by this, and after that this comes here pi by 2, and this divide, so that a is equal to pi by 6. Now we have 2b equal to minus a, and putting the value of a pi by 6, so that b equal to this comes here pi by 12. It means that value of a equal to pi by 6 and value of b equal to minus pi by 12. This is our answer. Now we take next problem. Now fourth problem, limit fx equal to 1 plus mod of x to power a divided by mod of sin x if x vary from minus pi by 6 to 0, and fx is equal to b if x is equal to 0, and fx is equal to e to the power tan 2x divided by tan 3x, where x varying from 0 to pi by 6. Now this is less than 0, 0 to power minus 1, minus 0 to power negative, so that here f is continuous and x is equal to 0, find a and b. Now f minus 0, limit minus 0, it means that we take these functions this, because this comes below minus 0. Now limit x tends to minus 0, 1 plus mod of sin x divide power of a by mod of sin x. Here for sin x, sin 0 equal to 0, and here 1 and a divided by 0 infinity, that is a to power infinity. Now solution of such type of problem, fx power gx, that exponential limit x tends to 0, gx bracket में fx minus 1, so that gx fx के power gx equal to this a by sin x, and fx minus 1, fx is equal to this 1 plus this 1 cancel. After that sin x also cancel, then only a, here e to power a. It means that function of 0 to the power minus equal to e to power a. Now f 0 plus means x vary from this 0 plus comes here, so that limit x tends to 0 plus e to the power tan 2x divided by tan 3x. Now we arrange this limit x tends to 0 plus e to power this, e to power this tan 2x by 2x, here multiply this, and tan 3x divided 3x multiply this, x and x remove, this is equal to 1, this is 1 by this is also equal to 1, 2 by 3 here, and 2 by 3 e to power 2 by 3. Now f is continuous and it is a given, so that f minus 0 and f 0 plus and f 0 e to power a, and here e to power 2 by 3, that is equal to f0, that is equal to f0 is equal to b, so that we take these two parts, this e to power a and e to power this, by in law of indices a is equal to 2 by 3 and b equal to e to power 2 by 3, so that value of a equal to 2 by 3 and value of b equal to e to power 2 by 3. This is our answer. Next, now we take another problem. Now, fifth problem, if f(x) is equal to 3 minus cot inverse 2x square minus 3 by x cube, if x is greater than 0 and f(x) is equal to this x square cos e to the power 1 by x less than 0, x less than 0, define function f so that f it is continuous. Now f(x) is equal to given functions. This is greatest integer notation of greatest integer. This is the fractional part of x square. Now limit f 0 to power minus 1 अर्थात we take this 0 x is less than 0, we take the function f(x) is equal to x square cos e to the power 1 by x square and cos e to the power 1 by x. We take this because 0 to the power minus, so that x square this is 0 and this is equal to cos 0 equal to 1, and after multiply this becomes 0. Now f0 plus here x greater than 0, so that f(x) equal to this part we take here. Now we take 3 minus greatest integer cot inverse 2x square minus 3 by x cube, and this is a 3, and here putting x equal to 0, this is 0, this is 0, this is minus 3, cot inverse minus 3, 0 minus 3 divided by 0, this is equal to infinity minus infinity, but this notation is greatest integer, so that greatest value equal to 3, so that we apply the value of this equal to 3 minus 3 equal to 0. Now redefine the functions. f(x) is equal to 3 minus cot inverse 2x square minus 3 by x cube, and x greater than 0 and equal to 0, function equal to 0 at x is equal to 0, and function is equal to x square cos e to the power 1 by x. If x is less than 0, this is our required result. Now we further discuss. Now graphically function is continuous or discontinuous, we define here. Here is a graph, and this is the x-axis and this is the y-axis. Here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now we discuss the functions at the point x is equal to 0, f0 is equal to f0 plus f0 plus. Here function is continuous at this point, but at f is equal to a, f is equal to a, left hand limit and right hand limit both are equal to 1, but f1 is not defined here. Here is a gap, so that function is discontinuous at this point. F is equal to 1. At f is equal to 2, function is continuous, and at f is equal to 3, here left hand limit and right hand limit this are defined, but both are not equal, because left hand limit and this is the right hand limit, there is a gap, so that function is discontinuous at x is equal to 3. Now at x is equal to 4, at x is equal to 4, left hand limit and right hand limit, left hand limit and right hand limit are equal but does not equal to at x at this point because here is a gap, so that left hand limit, right hand limit are equal but not equal to f4, so that this is not continuous at this f is equal to x equal to 4. Now at x is equal to 5, here both left hand limit and right hand limit, left hand limit go to the infinity, this is a negative direction, minus infinity, and this is go on in the positive direction, so that left hand limit and right hand limit both are minus infinity and plus infinity, so that this is a discontinuous at x equal to 5. Now we discuss further problems. Now last problem, verify functions fx is continuous at x is equal to 0 and 1 when fx is equal to mod of x plus x minus 1 and fx is equal to 1 minus 2x if x is less than 0 and 1 if x greater than equal to 0 and less than 1 and 2x minus 1 if x is greater than equal to 1. Solution at x is equal to 0, we test x is equal to 0 and 1. Function is whether continuous or not. X is equal to 0, f0 equal to 1, f0 equal to 1, so that left hand limit x tends to 0 minus 0 fx, that is limit h tends to 0 minus h, and limit 0 minus h here, that is 1 minus 2x. X is less than 0, we have used these functions 1 minus 2x here, so that 1 minus, that is a minus h, so that 1 plus 2x, and putting h is equal to 0, this is 1. And right hand limit x tends to 0 plus 0 fx, that is f0 plus this, that is equal to 0 plus h, limit x tends to 0, f1 0 plus comes in this, and that is equal to 1, so that left hand limit and f0 and right hand limit are equal, that is equal to 1. Thus function is continuous at x is equal to 0 and at x is equal to 1. Left hand limit x is equal to 1, f1 x is equal to 1, f1 1 minus 2x, 1 minus 2x, and here in this case 2, this is a f1, so that equal to 1, we take 2x minus 1, 2, x is equal to 1, 2 into 1 minus 1, that is equal to 1. Now left hand limit x tends to 1 minus 0 fx, 1 minus h, so that this is limit x tends to 0, f1 equal to 1, and right hand limit 1 plus 0, 1 plus 0, we take here f1 plus h, so that this 2x minus 1, 2 into x replaced by 1 plus h, 2 plus 2h, and 1 remove, so that 1 plus 2h, putting x is equal to 0, this is equal to 1. Thus, left hand limit equal to f1 and equal to right hand limit, so that function is continuous at x is equal to 1. This is our required result. Now, like and subscribe videos and share with your friends. Thank you.